As you get to this middle point of chapter 2, you start dealing a lot with linear functions in different formats. And the main format you're going to see a lot of is slope-intercept form, which you may know from your previous courses as being y equals mx plus b. However, your book represents it as y equals b plus mx. And the other thing you have to keep in mind is that other variables might be used. This is in slope-intercept form here, except you have c in the place of y, p in the place of x. So it's really important to keep in mind, depending on the format and the variables used, that first of all, a linear function is going to just have two variables involved. They're both going to just be raised to a single exponent. And the slope is the value that is being multiplied to the independent variable, and the constant value is going to be your y-intercept, or oftentimes that represents the initial value. So keeping those things in mind helps you identify what is being communicated in these various equations and what they represent. And it also helps you keep in mind of what units should be involved, because you're being told that this equation here gives the relationship between the number of people, which is P, at a bowling party and the total cost in dollars, and that's going to be what C represents. And so you're asked to match the coefficient or variable from the equation with the unit of measure it will have. So you have this 25 and 125, which are both constants. This 25 being the coefficient on the variable term is your slope. It's your rate of change. Therefore, you should be seeing something per something. You need to keep in mind that you want dollars here. This is people. So you have people being multiplied by this to convert to dollars. So it should be dollars per person, and that's why this 25 would be in dollars per person. Of course, this would turn into number of dollars, and this should be the initial amount in dollars. It's probably a fee that you had to pay to get the lanes that you needed to get, and then you would pay per person. So this would be the initial fee, and this should be in dollars. And so those are the units of measure that you would have for these two values. Of course, P would be in people, C would be in dollars as well. And here, the relationship between the balance B in dollars left on a mortgage and the number of monthly payments is given by this equation. So B is how much you owe still, N is the number of months. And one of the things you have to keep in mind is that sometimes you will have situations like this, but then they give you a situation where, okay, they're mentioning years. Here, 10 years is the same thing as 120 months. Just multiply that by 12. So this is the value that you're being given for N. You're looking for what B is. So you would substitute this in for N and carry through the calculation, and you would get 243,000 minus 81,000, which is 162,000. And the balance after 20 years, same thing. You're doubling this, so you're doubling the number of months, so that's going to be 240 months. You would substitute that 240 in for N and carry through the calculations needed to get $81,000 remaining. Now, at the same time, you've done problems like this in the previous lessons. How many monthly payments will need to be made so that the balance is under $100,000? So you're looking for number of payments now, or basically N. And so how many payments? Well, you want to get this under $100,000. So let's see, what will it take to get to $100,000 exactly? To get to $100,000 exactly, solving this equation, you would subtract 243,000 from both sides, and then divide both sides by negative 675, and you get that N is 211.85. So that means that's what would get you to exactly 100,000. Well, you can't make 0.85 of a payment, so when you make the 212th payment, you should be under $100,000. So at 212 payments, you'll reach that part where you're under $100,000 owed on this. And they'll say here, after how many years will the mortgage be paid off? Well, again, you're looking for the number of payments that have been made. When it's paid off, you owe nothing. So solving this equation, again, subtracting 243,000 from both sides, and then dividing both sides by a negative 675, you get that N is 360. So 360 payments have made, which means 360 months have gone by. You want to convert this back to years, so 1 year over 12 months, you'd multiply this by to convert it, and you would end up with 30 years. And so that's the amount of time it would take to pay off the mortgage. That is the end of this problem, as well as this video. If you have any additional questions, please make sure to bring it up during class.